In this video, we're going to talk about modeling functions using variation. Well, let's talk about the number of hours that you worked and your paycheck and how it's related. Usually, when you work a lot of hours, your paycheck is going to be pretty good, right? If you don't work a whole lot of hours, let's say you're sick, your paycheck is probably not going to be very good either. This is an example of what is called direct variation. Direct variation talks about as one variable increases or decreases, the other variable will also increase or decrease specifically. All right, so let x and y represent two quantities. The following are equivalent. 1, y is equal to k times x, where k does not equal 0. 2, y varies directly with x. 3, y is directly proportional to x. K is referred to as what is called a constant of variation. All right, so let's write an equation for each of the following. So we have P varies directly with B. So that's going to be P equal to, do not forget your constant of variation for these problems. So K times B. All right, A is directly proportional to the cube root of Y. Well, A equal to constant of variation times cube root of y. All right. Now, next thing I want to talk about, how many hours you watch of TV and the number of hours you study for your Math 103 test. How are they related? Usually, the more TV a person watches, the less studying they do. Or, if you're cramming for an exam, you might not watch a whole lot of TV one night, but you're going to do a whole heck of a lot of studying. This is an example of what is called inverse variation. As one variable increases, the other variable will decrease. So inverse variation, let x and y represent two quantities. The following are equivalent. Y is equal to k divided by x, where k and x are not equal to 0. Y varies inversely to x. Y is inversely proportional to x. And again, k is referred to as a constant of variation. So I want to be able to write an equation for each of the following. So P is inversely proportional to C. Well, I'll start with P. Again, do not forget your constant of variation. So that is K divided by C. So B varies inversely to the fifth of A. Now notice this does not say the fifth root of. So B equal to K divided by A to the fifth power. All right. A couple other variations I want to talk about. One is what is called joint variation. And that is going to be when one quantity is proportional to the product of two or more quantities. An example, the volume of a cylinder is pi r squared times h. Okay? Both the radius and the height are directly proportional to the volume. And in this case, pi is actually your constant of variation. Combined variation is when direct and inverse variation occur at the same time. All right, so let's write an equation for each of the following. S varies directly to T and D. Well, S equal to, don't forget your constant of variation times T and D because they vary directly. Okay, now V varies directly to P and inversely to Q. Well, that's V equal to K times P over Q. And I can rewrite that as Kp over Q. Okay, for the next couple of problems then, I want to determine the constant of variation and then construct the function that is expressed in each statement. So let's start with W is directly proportional to L. W is equal to A when L is equal to 1. So first of all, I want to write my equation. W is equal to K times L. Now, what do you know? W is equal to A, and L is equal to 1. Well, K times 1 is K, So A is equal to K. That's my constant of variation. Now, go back and plug that into the original equation, and W is going to equal A times L. All right, so now let's go to P varies inversely to I when I is equal to 21 and P is equal to 12. So let's write first P equal to, again, don't forget your constant of variation, and because it varies inversely, we're dividing. So P is 12 and I is 21. 12 times 21 is 252 because I multiply both sides by 21. Now go back and plug that in to K here. So that's P equal to 252 over I. All right, a couple others I want to take a look at then. W is directly proportional to R and the square of I when W is equal to 125, I is equal to 5, and R is equal to 3. So we need to write this out first. Okay, don't forget your constant of variation. Directly proportional to R, square of I. Now that is not the square root of I, that is I squared. Now, plug in what you know. You know W is 125. We know R is 3. And we know I is 5. All right, so simplify the right-hand side. 5 squared is 25 times 3 is 75, so it's 75 times K. Divide both sides by 75. And then I can divide out of 25 from the top and the bottom. And that's 5/3. So again, go back and plug that in for K. Okay, so let's scroll down then. P varies directly with B and inversely to A when F is 36, B is 12, and A is 5. So first off, let's write. Again, don't forget your constant of variation. Directly with B, so I multiply. Divide by A because it's inversely. Now, plug in what I know. F is 36, B is 12, and A is 5. So multiply both sides by 5, and then divide by 12. And K is equal to 15. Now, go back and plug that in here. All right, so the one application problem that deals with variation would be this. The volume of gas in a nitrogen gas shock absorber varies directly with the temperature of the gas and inversely with the amount of weight on the piston. If the volume is 10 inches cubed at 80 degrees Fahrenheit with a weight of 600 pounds, then what is the volume at 90 degrees Fahrenheit with a weight of 800 pounds? So before anything else, we need to write an equation. So volume of a gas in a nitrogen gas shock absorber. I'm going to use V for volume. Again, don't forget your constant of variation. Directly with temperature, I'm going to call that capital T, and inversely with the weight of a piston, I'm going to call that W. Now, what pieces of information am I going to use here? I'm going to use 10 inches cubed, 80 degrees Fahrenheit, and 600 pounds. So I can determine what my constant of variation is going to be. So the volume is 10. The temperature is 80. And it's 600 pounds. So multiply by 600. And then divide by 80. So that should be 75. Now, go back and plug that in. Now, but that hasn't answered my question. The question is, what is the volume at 90 degrees Fahrenheit and a weight of 800 pounds? So now that I know what the constant of variation is, I'm going to use that equation now to plug in what I know. Volume, that's what I'm trying to determine. So it's 75. The temperature is 90. And the weight is 800. Don't forget your appropriate unit of measurement. That is what the volume is going to be at 90 degrees Fahrenheit with a weight of 800 pounds.